Let's start to continue our lectures about respiratory chain and oxidative phosphorylation. In this lecture, we'll be continuing to know what is the enzymes of electron transport chain, how they are arranged in the inner mitochondrial membrane, and how the flow of hydrogen and electrons among these enzymes will be created, electrochemical potential is created. Let's start. This is the electron transport chain. The electron transport chain present in inner mitochondria. Its concept is oxidizing NADH into NAD, and this is the oxidation of this NADH will be the final acceptor. The respiratory chain. It is a forming of carrier enzymes arranged in inner mitochondrial membrane for oxidation reduction till the final acceptor of hydrogen is oxygen forming water. Again, why NADH is oxidized into NAD and the oxygen is is receiving hydrogen forming water directly without. This is a series of electrons, series of carrier and proteins, because this results in rapid increase of energy. So we forming this to form gradual increase and exponential for gradual release of energy for gradual formation of ATP. This NADH is oxidized into NAD. This is oxidation. ATP is forming into ATP. This is a phosphorylation. So we couple oxidation and phosphorylation. The respiratory chains, which is a carrier enzyme, are arranged into 4 complexes. 1, 2, 3, 4. Complex 5 is concerning with ATP synthesis to forming ATP. Now we will starting in the first complexes, which is NAD dehydrogenase complex. As regarding 4 complex 1, the complex 1, which is NADH, is oxidized into NAD. This is the complex 1. It is formed of NAD dehydrogenase enzyme and the prosthetic group. What is the prosthetic group? It is FMN. This is a component derived from vitamin B, like riboflavin, and iron sulfur centers. NADH is oxidized into NAD, in which fat FMN is reduced into fat H2, and then reoxidized again by reduction. It is occurred by iron. Ferrous is converted into ferric. So this part is oxidized and this part is reduced. And the final, this is the complex 1. And the final acceptor of hydrogen, it is the CoQ. It is reduced into CoQH. So the complex 1, it is formed of enzyme called, this is the NAD dehydrogenase, and contain prosthetic group, which is the FMN, and several iron sulfur centers. The final acceptor of hydrogen is the Q, to reduce into CoQH2. This NADH is plus Q, in which NADH is converted into NAD and the Q converted into Q. Again, let's summarize the complex 1. Complex 1, it is starting from NADH. NADH, I was to oxidize into NAD. What is happening? The final acceptor of this hydrogen is Q. So NADH is oxidized into NAD, synchronized with reduction of the CoQ into CoQH2. This is the prosthetic group, prosthetic enzyme. This is enzyme of the complex 1 is called NADH dehydrogenase, and the prosthetic group called FMN and iron sulfur protein. As the NADH is oxidized, this is a gradual oxidation reduction of these 2 prosthetic group to the final acceptor of the CoQ. The form of oxidation reduction of FMN and the iron sulfur protein in the form of electrons. Take care. But the form of oxidation of NAD is oxidized or reduced by NADH. Is the same as the CoQ. It is reduced into CoQH2. But oxidation of FMN is occurred by reduction, the oxidized and reduced form by carrying 2 electrons. It is the same as iron sulfur proteins, oxidation and reduced by accepting electrons. Electrons passing through a series of iron sulfur centers and to, as I mentioned, to the final acceptor is the CoQ which reduce into CoQH2 by hydrogen. CoQ accept hydrogen. What means by hydrogen? As we said in the first lectures, hydrogen, two hydrogen, it means 2 electrons and 2 protons. What is iron sulfur protein? Iron sulfur protein, it is non-heme iron protein. What means that? This is a protein containing iron, not in the ring called protoporphyrin ring, which is present in heme. Iron sulfur proteins, as we discuss later, they are present also in the complex 1, 2, and 3. It is a take part in single electron transfer reaction. It is undergo oxidation reduction between ferric. This is ferric. When it is, this is the ferric. This is the oxidized form. It is reduced into by accepting reduction. By accepting electrons is converted into ferrous. So this is the complex 1. It is called the NAD dehydrogenase enzyme and the process. What is the component of complex 1? NAD dehydrogenase enzyme and the process group called FMN and iron sulfur proteins. At the end of the complex 1, NADH is oxidized into NAD. At the final acceptor is the QH is reduced into QH2. This is directly? No. This is passing in gradual group, passing through the prosthetic enzymes, which is FMN and iron sulfur proteins. The oxidation reduction in these protein groups again and again in the form of electrons, but NADH and the CoQ is oxidized and reduced in the form of NAD, in the form of hydrogen by accepting 2 electrons and 2 protons. The complex 2, this is the here, it is the FAD. This is the complex 1. This is the complex 2. The complex 2, it is the FAD H2 is converted into FAD. And this is the electron passing from FAD H2 is passing to the Q. So the Q is reduced into from Q to the QH2. Will be receiving the hydrogen either from NAD, which is a complex 1 through the NAD dehydrogenase, or receiving it from FAD H2 into by the complex 2, which is FAD dehydrogenase. Okay, let's shift to another complex, which is the complex 2. The complex 2, it is the called succinate, it is attached, it is the complex 2, it is the FAD H2. The FAD H2 linked to oxidation of succinate to fumarate. This is the one component taking in TC cycle. This is called succinate dehydrogenase or glycerophosphate dehydrogenase. This is the two enzymes, most properly enzyme used to FAD as a reducing equivalent. This is a coenzyme 2. This catalyzes oxidation of FAD H2, transferring their hydrogen also like complex 1 to coenzyme Q. It is composed of, this is enzyme which is called succinate dehydrogenase and the prosthetic group. What is the prosthetic group? FAD and F and iron sulfur. The previous one, complex 1, is the succinate dehydrogenase. It is the NAD dehydrogenase. It is iron sulfur, okay, but instead of the FAD, it is the FMN. FAD H2, it is the not free like NAD. NAD, it is a free. NAD and the NAD H is free like in membrane. FAD is oxidized. The FAD H2 is oxidized again to FAD. It is reactions of the oxidations of succinate to fumarate. It is reoxidized again by passing its 2 hydrogen, passing through the 2 previous prosthetic group into QH2. QH2, it is reoxidized again by complex 2. They are receiving the FAD, which is the FAD succinate dehydrogenase. This is the coenzyme, it is the FAD, and the prosthetic group, the other is the iron sulfur. The electrons, 2 electrons and the proton from the FAD passing to FAD from succinate dehydrogenase passing through the FAD, and each electrons passing, single electrons passing through the iron sulfur protein and to converted into FAD H2, iron sulfur protein, and converted to the QH2 forming QH2. Unfortunately, the redox potential from passing hydrogen passing from FAD H2 into Q forming QH2, this not result in no enough energy is produced. So no proton is pumping here in inner mitochondrial membrane. This is energy, it is low level of energy, and it can't be used to pumping electrons here to the inner mitochondrial membrane. The free energy drop from NADH2 to passing to the CoQ, as we said, this is the free energy, this is energy, it is enough to pumping protons to the inner mitochondrial membrane. However, the passing hydrogen from FADH2, succinate dehydrogenase, as other enzyme, I said to you, in the FADH2, it is the coenzyme of the two enzymes, which is succinate dehydrogenase or glycerophosphate dehydrogenase. The energy of transferring hydrogen from FADH2 to the CoQ level, it is the same. Both are roughly the same level of energy. No enough FADH2, it is not higher level of energy. No, it is present as roughly as the same stage. There's the same step of the stairs. So no energy is released. The amount of free energy, it is not enough to transfer electrons, release as a transfer electrons to the QH2. It is not enough for pumping electrons, as it is passing from NADH to the Q, because NADH, it is upstairs than CoQ. Passing hydrogen from this to CoQ, this resulting in energy release and the pumping proton. However, FAD, it is present as the FADH2, the hydrogen, it is present as the same stage as the CoQ. So passing hydrogen from here, from FADH2 to CoQ, no free energy enough is released. No pumping of proton. So, hydrogen, it is hydrogen present from NADH will be converted into NADH converted into oxidized, and this is the electrons will passing into proton, and electrons and proton passing into CoQ, forming QH2. Yes, this is a complex one. يبقى Q forming QH2. This is a hydrogen. Either it is receiving from NADH2, this is a complex one by NAD dehydrogenase, NADH dehydrogenase, or QH2 will be forming hydrogen from FADH2 by the complex 2, which is called succinate dehydrogenase. When the hydrogen passing from, this is a higher level of energy, from NADH to CoQ, this results in releasing of free energy. This is free energy used enough to pumping proton to inner mitochondrial space. However, passing of the FADH2, hydrogen from FADH2 to the QQ, it is the same stage of energy. No free energy is released for pumping proton, so no proton is pumping here. Then we having here QQ. This is we take complex 1, just take complex 1, which is the NADH dehydrogenase, and they take complex 2, this is passing here, like here, and we taking complex 2, which is the succinate dehydrogenase, and then forming Q is reduced into QH2. What is next? Q to be converted as we agree. This is the respiratory chain oxidation reduction. Oxidation reduction. This is reduced into QH2. To regain again into Q will be result in reduction of some sort called cytochrome C. So this is the complex 3. So what is first? Let me explain to you what is the CoQ, and then what is the cytochrome. This is will be remembered here. This is cytochrome C. It is the complex 3. It is the cytochrome C, and this is the 4, which is called also cytochrome C. This is cytochrome C complex oxidoreductase and the 4 oxidase. Yeah, so will be remaining the respiratory chain to cytochrome. What is the CoQ? CoQ, it is work as a collecting point. CoQ is a collecting point to forming QH2. This is collecting hydrogen, either from complex 1, NAD dehydrogenase, or complex 2, succinate dehydrogenase. CoQ, it is a mobile component. What means mobile component? It is not fixed. Complex 1 and 2 are fixed, but CoQ, it is a mobile component of respiratory chain. It is the quinone derivatives. It has tail. This tail, it is hydrophobic isopronoid tail. This structure, it is resembled to vitamin K in the structure. It is the vitamin K, and this contain hydrophobic, so it is the lipid soluble. At the mitochondrial membrane, it is the lipid, so it is the lipid soluble, so it is the mobile. It is free and it is not fixed like the others. Its component, which is its long hydrophobic isopronoid tail, resemble the structure of vitamin K and vitamin E, which are vitamin fat-soluble vitamins. They are the collecting point of receiving hydrogen from the complex 1 and the complex 2. Passing complex 1, passing hydrogen to CoQ. Complex 2 is starting to enter hydrogen to CoQ either through the complex 1 or through the complex. What about cytochrome C? The remaining members of electron transport chain are cytochromes protein. Cytochrome containing iron. However, the iron presenting in cytochrome, it is present in the ring calling porphyrin as it is present in the heme. Remember, complex 1 and 2 containing iron, but iron present in iron sulfur. Take care. When I mentioned iron, so the iron present in the two form. Either it is the oxidized form, which is called ferric. On adding electrons, it is converted to reduced form of containing gold. It's called ferrous. The cytochrome containing iron fluctuating between oxidized form and reduced form. It is accept and donate electrons in oxidized and reduction as it occur like other components of respiratory chain. You have to differentiate this from hemoglobin. Hemoglobin containing, this is like iron of hemoglobin. Always hemoglobin containing iron is present in the reduced form, which is called ferrous. If it is converted to ferric, it is non-functional, it is a meat hemoglobin, non-functioning hemoglobin, can't carry oxygen. But in respiratory chain, normally it is fluctuating between oxidized and reduced form of. As we see, this is a CoQ. This is a CoQ, which is carrying hydrogen. This hydrogen, it is carrying from NADH, which is the complex 1, or carrying from succinate dehydrogenase, either passing from this or passing from this. Passing from complex 1 to the CoQ, passing hydrogen from NADH to CoQ, resulting in releasing of energy. This resulting in pumping proof. Okay, what is here? CoQ passing its hydrogen to cytochrome C. To passing through cytochrome C is a mobile, and this is a complex 1, complex 2, passing through the complex 3 and the complex 4. The complex cytochrome C, the complex 3 causing reduction of cytochrome C. We called cytochrome complex 3 cytochrome C oxyreductase, while complex 4 resulting in oxidation of cytochrome C. So we called complex 4 cytochrome oxidase. Now we will starting to discuss what is the complex 3. Complex 3, this result in reduction, transfer of hydrogen from coenzyme Q to cytochrome C. To transferring this is hydrogen passing through the prosthetic group. This prosthetic group called cytochrome B, iron sulfur, and the cytochrome C1. Remember, passing of this part reducing form in the form of not hydrogen, it is in the form of electrons. Passing here from NADH to CoQ, it is CoQ carrying QH2. NADH2. Fat H2. But is when I said iron passing oxidized and reduced in the form of electrons, like cytochrome. The difference between iron, as I said before in the previous slide, the iron, it is present as iron sulfur or present cytochrome containing iron. When I said iron, so it is oxidized and reduced by passing and removing electrons. The iron present here, it is attached free iron sulfur, but here it is present in iron containing porphyrin. Okay, what is the complex 3? Complex 3, again, it is passing hydrogen from CoQ enzyme into cytochrome C, passing through prosthetic group called cytochrome B, iron sulfur protein, and cytochrome C1. And they are responsible for reduction of cytochrome C, so we call the complex 3 cytochrome C oxyreductase. Cytochrome C, this is the only mobile part, is carrying electrons, this transforming final to complex 4. Cytochrome C carrying electrons from here to transfer it to the oxygen. This is discussed. This is complex 4. It is accepting electrons from transferring electrons from CoQ to cytochrome C. This is the complex 3 passing through the prosthetic group cytochrome B, iron sulfur protein, and cytochrome C1. This is the prosthetic group of the complex 3. Passing electrons from the coenzyme Q to cytochrome C. This is called reduction of cytochrome C. We sometimes call this is the complex 3 or cytochrome C oxyreductase. So passing to cytochrome C and then passing to the another complex which is the complex 4. Transferring of electrons from complex 3 is the complex 3 which is containing cytochrome B and C1. It is a higher level of energy than cytochrome 4 which is containing cytochrome 4 which is called cytochrome oxidase. Transferring of energy, this is stored as pumping of proton. So when this passing electrons from complex 3 to another complex which is a complex 4 resulting in the releasing of energy, and this energy is stored to pump electrons. So when the proton is passing from complex 1 to the CoQ resulting in pumping electrons. Passing from complex 2 to cytochrome Q, no energy, no pumping electrons. Passing of hydrogen from the complex 3 to complex 4 also resulting in releasing of we're reaching to this level, which is a cytochrome C. So complex 3 taking the hydrogen from CoQ into electrons, converting it into cytochrome B to iron sulfur protein cytochrome C1, passing to cytochrome C. Then we reaching this level. We want to this level, which is shifted to the level complex 4. Complex 4 will be taking electrons from cytochrome C to oxygen and forming water. Complex 4 is called cytochrome A and cytochrome A3. Cytochrome A and E3. This is complex 3 causing reduction of cytochrome. So we called it complex 3 cytochrome C oxyreductase. Complex 4 resulting in oxidation of cytochrome C. So we called this is the complex cytochrome C oxidase. When I'm asking you, what is the final acceptor of hydrogen, of electrons, in the respiratory chain, you told to me oxygen. Oxygen, it is the final one to accept hydrogen. It is the oxygen forming water. What is the oxygen oxidase, which is the reduced oxygen? This is reduced oxygen. This is give electrons. This is the final one in the respiratory chain. It is called cytochrome A3. Cytochrome A and cytochrome E3. This is the complex 4. Again, passing of hydrogen from this complex to oxygen forming water will be resulting in energy, and this is energy we're using to pump electrons, resulting in free energy. Complex 1 pumping electrons, passing from complex 3 to complex 4 pumping electrons, passing from the complex 4 to oxygen, this resulting in the free energy. The complex 4, it is called cytochrome C oxidase. Its component is cytochrome A and E3. It is a catalyzed final acception of hydrogen is oxygen to forming water. It is the only hypothetical in every one proton, 2 proton is received by half molecules of oxygen forming water. It is the only irreversible reaction of the chain. As we said, oxidation reduction, it is a reversible reaction, but it's the only once the hydrogen is coming to oxygen and forming water, it is the irreversible. And these need cofactors cover. Concentrate every complex 1 and 2 and 3 needing iron as cofactors. The only factor that require copper as a cofactor, the only complex, it is the complex 4. Energy is released. It is it is used to pumping electrons to inner mitochondrial membrane. The final acceptor of oxygen, the respiratory chain. This is a cytochrome C. This is needing covers. It is also present in oxidized and reduced form. Passing to complex 4. The complex 4, it is formed of the cytochrome A and E3. And this is protons will be coming to half molecule of oxygen to forming water. The energy result from transferring to complex 4, this is resulting in increasing amount of energy, and this energy is used to pumping protons to inner mitochondrial membrane. uncouplers and regulation of respiratory chain will be inshallah taking in the fourth lectures. After this, two condensed long lectures of the 2 and 3 oxidative phosphorylations lectures. Let's start to testing our knowledge. Which of the following is a prosthetic group of NADH dehydrogenase? NADH dehydrogenase, it is the complex one. What is the prosthetic group of complex? Thank you.